This is my Keypad Matrix Echo. It consists of an AT-Tiny84, an SN74 HC595, a keypad which has 8 pins, and this 8x8 LED matrix. So with the keypad off, we can see the wiring where the keypad was. We have 7 outputs from the keypad, and then right here there's a common pin. So on the keypad, I've marked down C for common pin. That's on the left side. Then we have 3 row pins, or 3 column pins, and 4 row pins. So that will map out where everything is. So if you click a 1, it would be like row 1 at the top, column 1 on the left. So those outputs from the keypad go into port A on our AT-Tiny84. The wires coming from the Arduino, these 2 right here, the green and black, that is power and ground. These other 4 right here are pins 10 to 13 from the Arduino and go to reset, MOSI, MISO, and clock on the AT-Tiny84. These 3 wires coming out from the AT-Tiny84 go to data, latch, and clock on the 595 shift register. And then from the shift register, we have 7 outputs that power the 3 columns and 4 rows for our 8x8 matrix. While doing this project, we are using lower register level code. So I'm going to talk about a bit of it. So right here we have DDRB. This is addressing the pin mode in high level would be called of the B register. So to set PB0 is our data pin, PB1 is our latch, and PB2 is clock. So to set PB0, 1, and 2 to output, we have to do OR equals 1 shifted left PB0. This will set the PB0 and then PB1 and PB2 to 1, which is output in register level. So the next line here is port A equals the inverse of DDRA. So by default, DDRA would be 0 or input, and we want input pull-ups on port A pins. So we can use this port A saying that all the port A pins will be equal to the inverse of 0. So the inverse of 0 would be FF, or all ones, 255. So that would turn the port A pins to high, and when something is an input and high, it means it is an input pull-up. So next thing is my shift out code. So this takes a UN8 value, and it will, while it's less than 7, it will add it up. And then we have an if statement, then a not here, but I'll talk about that later. So that it has pin A. Pin A just says read the byte from A, and then I'm comparing it with a mask that will switch some of them from highs to lows. So we have the matrix will work. I'm ANDing it with 1 bit shifted left bits. So that will be like the 0 to 7. And then if that all equals low, or if the not of that equals low, then it will do this command, which is port B or equals 1 bit shifted left PB0, which is our data pin. So it's shifting 1 to the data pin. And if it's not low, then it will go port B and equals 1 bit shift left data pin. And then it will send a clock signal. So port B or equals 1 bit shifted left PB2, and then send it, that's high, and then convert it back to low. And then that's my shift out function. And then here is what would be in the loop. So port B and equals the inverse of 1 bit shifted left PB1, that will set latch low. And then we have the shift out function, and then we make latch high, and then that will do the shift out. So that will send out one of the LEDs to turn on in our matrix. So now I have the board plugged into the Arduino. So if I press a button, it will show up on the matrix. So the top left corner shows up right there. I'm holding it down, so But once I press it and let go, it should stay on for 300 milliseconds. And then I can show the bottom right is right there, and middle, left. So that's how it works with the code I showed earlier.